With this first question, you want to prove that this bottom triangle, AMC, that triangle is isosceles. In order to do that, we have to look at the top two triangles and prove the top two triangles congruent. First information you're given is that AB is congruent to CB, and BM bisects angle ABC. That's given. Okay. Step two, after I fill that information in my picture, step two, you're gonna look at the vocabulary words. Bisects. Pay attention to what you are bisecting. You're bisecting an angle. So when I bisect an angle, I get two new angles, or two smaller angles that are also going to be congruent to one another. So if I look at angle ABC, which if we look at angle ABC, that angle right there, and I bisect it with BM, the two new things that are created are angle 1 and angle 2. So I'll say angle 1 is congruent to angle 2. The reason for that is the definition of an angle bisector. So now I know angle 1 is congruent to angle 2. Looking at my picture, I also know that BM is congruent to BM. That's the reflexive property. So I've got this triangle, or that segment there, congruent to itself. Okay, if you were to tear those two triangles apart, you'd have something that looks something like that. When you've got this angle 1 and this angle 2, they're congruent. You got that segment congruent to that segment, and now this segment congruent to that segment. So now you've got side angle side. So those two triangles are congruent. So I'm going to name them triangle ABM is congruent to triangle CBM by side angle side. Next thing I know is that, I want to start talking about this triangle down here being isosceles. Well, if that was isosceles, then I would need to know that this segment and that segment are congruent, okay? And because those segments show up as corresponding parts in the congruent triangles from step 4, I can say now that AM is congruent to CM by CPCTC. And step 6 then, now that I know in this bottom triangle that this segment here is congruent to that segment there, okay, I now know that this triangle on the bottom is an isosceles triangle. So I'll say now that triangle AMC is isosceles. Oh. The definition of isosceles triangles. Going down to these questions, told you that the best thing to do is to draw a picture with these. You don't have to with the first one, but BAD is going to go to TOP, then DB, that letter and that letter should match up to P and T. So I'm going to say segment P, T. Now if I go P, if I rename it, reorder as triangle PTO, I went last letter was first, okay? So last letter here is P. They changed it to make the first letter. So I'm going to take this last letter here and make that my first letter. And then they go to T. So T was the first letter. So I go over here and I find my first letter, and it's B. And then I'm left with A. So DBA. The second picture, you need or second question, you need a picture to organize the information. They say triangle EFG is isosceles, with the measure of angle G being 94. Well, if that's 94, then 180 minus 94 is 86. So these two angles here have to add up to 86. But they're going to both have to be 43 in order to justify the idea that it's an isosceles triangle. Okay? Remember, one triangle can't have an angle can't have two angles that are obtuse. 94 is obtuse, so that means these two angles have to be acute, and therefore those are the two that have to be congruent. So now this side here would be congruent to that side there. So the legs are sides EG and FG. And measure of angle E, that angle right there, is 43. If I wanted to look at the question number 3, it says triangle ABC is congruent to triangle XYZ. So now it says you have shown AB congruent to XY. You've shown AC congruent to XZ. Now they want you to prove the triangle is congruent by side angle side. So you must also know what? Well, in order to prove the congruent by side angle side, I've got a side, and I've got a side. Side angle side says you need to sandwich an angle in between them. So it's got to be that angle there. Same thing down here. A side and a side, but side angle side says sandwich an angle in between. So angle A has to be congruent to angle X. The next part says, well, what if you wanted to prove it by side, side, side? Well, I've got this side congruent to that side congruent to that side. Now I've got to have CB congruent to ZY. So I'd say segment CB congruent to segment ZY. A method that can be used to prove right triangles congruent but cannot use other triangles is the hypotenuse leg method. Nothing else. No other triangles have hypotenuses. Number 5 says CAP and TAP are equilateral and coplanar. AP is a common side of both triangles. So AP is in both triangles. So I'm going to draw a triangle CAP. Any triangle you want. I'll go ahead and do this work down here. Maybe. There we go. I'm going to take CAP. So we got triangle CAP drawn there. It's equilateral, so it's got to be equiangular. So this is 60, 60, 60. It tells me that the other triangle TAP is coplanar with CAP, and that it shares side AP. So now I've got to draw another triangle like this. Now that'd be triangle TAP, where AP is in both triangles. So this would be 60, this would be 60, and this would be 60. So now it asks you, what is the measure of angle CAT? Well, C to A to T is that angle there. So 60 plus 60 is 120. Okay. Doing this bottom one says triangle ABC. You know A to be 50 degrees. You know C to be 80 degrees. And AC is 7x plus 8. And BC is 38 minus 3x. Okay, now here, these are our variables, or the expressions are variables, so we have to be able to relate those things to one another. How do I do that? Well, I've got to look at this triangle and know that that's 50 degrees, so it's an isosceles triangle. So this side here is congruent to this side here. So I can take 7x plus 8, set it equal to 38 minus 3x, add 3x to both sides, subtract 8 from both sides, so x ends up being 3, and that's my answer. Looking at this question here, we've got some parallel lines cut by transversals, giving you a lot of the information here. They want to know why is angle 2 congruent to angle 4. If I look at angle 2, it is created by that parallel line, that transversal. These two angles are alternate interior angles. So your reason here for number 4, I'm not going to write it out, but it's the same as angle, or step number 2 was. Okay. Now, why is AC congruent to AC? That's your reflexive property. Spell it right. Okay. And now what you know is angle 1 and 2, or sorry, 2 and 4 were congruent, 3 and 1 were congruent, and now you've got this line down the middle congruent, so these two triangles are angle, side, angle. They're congruent by angle, side, angle. Down here, PQ is congruent to QR. We know that because Q was the midpoint of PR. So definition of a midpoint. QPT is this angle right here, and RQS is that angle right there. We know them to be congruent because these parallel lines were cut by a transversal, and those two angles that I've highlighted here are corresponding angles. So I'm just going to write corresponding angles are congruent, but the real reason is if two parallel lines are cut by a transversal, then corresponding angles are congruent. So now I would have this segment here and that segment there congruent, because that was given. And I've also found this segment here and that segment there to be congruent. I know the picture's small, but you got side, angle, side, and that's why your triangles are congruent. And the last one, we're told that segment bisects a segment. So if a segment bisects a segment, it cuts that segment into two equal parts. So why is WP congruent to XP? Definition of a segment bisector. Now I gave you points. I accepted your answer if you wrote definition of a midpoint. Nowhere to tell you you have a midpoint, so I shouldn't have. We want to use the word bisects. Okay, that's how we know that those two segments are congruent. Same reason here for number 4. Definition of a segment bisector. So now I know that segment's congruent to that segment. I should probably put the correct amount of hash marks in here. So now you've got 3 sides in this triangle congruent to 3 sides in this triangle, so you got side, side, side. A lot of people try to put side, angle, side because they knew that this angle here was vertical to that angle. All right? And you're right, that would work, but nowhere in your proof does it use vertical angles. And nowhere have you told me that those angles are congruent, so you can't use side, angle, side. Go off of the steps that you're using and the statements that you make to back up this here. If I use side, angle, side, and I go through there and I say, nowhere do I talk about an angle, so how are they using side, angle, side? Okay, all we do is talk about sides, so we got to use side, side, side.